All right, so a square matrix is said to be invertible if its action can be undone. All right? In other words, if I know the vector B then the output of the action of matrix A, that's enough information for me to determine the vector that it acted on, this X. All right, so that implies that there cannot be more than one solution. The null space of matrix A must be trivial, because as we saw, any non-trivial element of the null space of matrix A could be added to any vector X without changing the output of AX. All right? So this implies that A has a pivot in each column. All right? Now, moreover, we need X to be able to be determined from the action of another matrix on B. And this is going to be the inverse matrix. Okay? The inverse matrix acting on B. This implies something interesting, because it can't be the case that there's no solution. So I'll say it like this. It's not possible for AX equals B to have no solutions if A is invertible, because that would imply that you can't act with A inverse on that B for which AX equals B had no solutions. A inverse is going to be able to act on every vector in the space. So that implies that A must have a pivot in each row. Okay? So in order to be invertible, a matrix must have a pivot in each column and a pivot in each row. So it must be square. It's not possible to have an invertible matrix that's not square. Now, once we agree to consider only square matrices, there are a large number of statements that we can make that are all equivalent to the statement matrix A is invertible. Okay? I'm just going to give a couple of these, but there are a huge number of them. Okay? Given the square n by n matrix A following statements are all equivalent to the statement matrix A is invertible. A has a pivot in every column, A has a pivot in every row. A represents a one-to-one mapping. A represents an onto mapping. The null space of A is trivial. AX equals B has exactly one solution. A is row equivalent to the identity. The rank of A is n. The columns of A are linearly independent. All right, and we could, of course, continue from here. You can see why, from this perspective, there are so many equivalent statements to the statement matrix A is invertible. This list of statements is collectively referred to as the invertible matrix theorem.